Hello, and welcome to 5-Minute Math. Today we are looking at the 5th grade concept of dividing whole numbers and unit fractions. This is 5.3L Readiness Practice, the Proficient version. If you are interested in exploring the 5.3L Readiness Practice for the intermediate or advanced versions, or the Readiness Practice resource line with any other standard, you can find those by using the link in the video description. So we have a baker with half a bag of flour who wants to divide it equally among 5 bowls. So let's draw a half a bag like this, right? And I'm going to draw my half, I kind of do it like this. So I've got half a bag of flour, and we'll just kind of shade it like this. So there's my half a bag. I want to give myself plenty of room. And it is going to be divided into 5 bowls. The question is, how much will each bowl get? Well, what we could do here is we can take our 1/2 and we can divide it into 5 equal parts. So I'm just going to cut this into fifths. And there we go. I've taken the whole, cut it into fifths, but by doing the whole, I've also got a half. And you'll notice now I've got a new fraction. So my new fraction, I'll do that in green here, is going to be 10 parts, 1 out of 10 parts. So I've got 1/10 in each of these. And I can draw that down here. I've got 5/10 total on the bottom. 5/10 is equal to 1/2. So I just took my 1/2, cut it into 5 equal parts. And so I can say each bowl will have, and we'll say 1/10 bag of flour. And if we wanted to represent that with an equation, we can take our 1/2, we could divide that by 5, and that's going to get us 1/10. Now, how can we do that without the picture? Well, let me show you down here. When we divide by a whole number, that's the same thing as multiplying by its reciprocal. So we can take our 1/2, and then instead of the division, we can use the reciprocal, which is multiplication. And instead of the 5, which is really 5 over 1, I could flip that upside down. That's called the reciprocal. And I can do 1 over 5. So whole numbers are fractions over 1. And if we multiply straight across, we get our 1/10. So you can do it with a picture, or you can use it by, when you're dividing, you can end up multiplying by the reciprocal. That works as well. For our second problem, we've got Liam. We've got 6 chocolate bars, wants to share them equally among himself and 3 friends, giving each person an equal piece. How many total pieces will of chocolate will Liam give out? Well, let's see. I'm going to just draw my 6 chocolate bars here. And even though you see the number 3, we should note that there are 4 people here. I've got Liam. He's going to share it amongst himself and his 3 friends. Okay, so I'm not sure how to break 6 into 4 equal pieces, but what I can do is I can break each of these bars into fourths. Okay, and so I can do it like this. I'm just going to cross these off and take a look. How many total pieces will Liam give out? Well, look, I've got 4, 8, 12, 16, 20, and then 24. So we can say Liam will give out, and we can say 24 pieces. Now, how can we do that with an equation? We can take our 6 pieces, and what we did, right, is we divided it by 1/4 pieces. Now, how does that get us into 24? Well, same thing. We are going to, instead of dividing by a fraction, we are going to, let me change my color here. We're going to multiply by its inverse. So we're going to take the reciprocal of division, which is multiplication, and we're going to take the reciprocal of that 1/4, which is 4 over 1. You just flip it upside down. Now 4 over 1 is just 4 wholes, so really it's 6 times 4. So that gets you your 24. For our third problem, we've got John, and he's got a third of a pizza, and he wants to divide it equally among three friends. So they're not going to get very much of the pizza. So let's do this. Let's draw a rectangular pizza, and I'm going to just go ahead and, so we're going to pretend like it's a deep dish. I'm going to cut it into thirds. Okay, so we're going to say it's this bottom third right here. Now, before we do this, let's see what happens if we use our equation first. We're going to take 1/3, and we're going to divide it equally among three friends. So we're going to divide it into three parts. Okay? Well, that's the same as if I take the inverse, that's multiplication, and then I take the reciprocal of 3, which is really 3/1, and we're going to flip that upside down. So I'm thinking it's going to be 1/9. Let's see if we can take this third, and now we're going to take that third and divide it into three parts, which is really another third. And so look, I've got three pieces here, and each piece is going to be this 1/9. All right, so we can answer that question. Each friend, let's see, receives 1/9 of the pizza, which is not very much. Now, will that amount of each friend received be more or less than 1/10? Well, let's compare these two now. I've got 1/9 and I've got 1/10. Now, they do not have the same denominator, but they do have the same numerator. And you can compare fractions if they have the same denominator just by looking at uh, the denominator itself. So 9 parts versus 10 parts. Well, as the parts get larger, each of those pieces get smaller. So 1/9 is going to be just slightly larger than 1/10. And think about it like this. What if we had 1/9 and 1/2, right? We know that 1/2 would be much larger because the 9 is larger than the 2, which means those are smaller pieces, right? What if we had 1/2 and 1/100th? Well, that 1/100th is going to be microscopic. As the denominator gets larger, the pieces get smaller. So, since the 10 is larger than the 9, the piece is just slightly smaller. So that will be our answer as well. That 1/9 is going to be slightly larger or more than 1/10. If you're interested in exploring the 5.3L Readiness Practice resource aligned with the intermediate or advanced versions, or the Readiness Practice resource aligned with any other standard, you can find those by using the link in the video description.